Hey guys, I'm Jay. Today is my LeetCode review vlog on the 289th problem, Game of Life. The Game of Life board is made of an m times n grid of cells, where each cell has an initial state, life represented by 1 or dead represented by 0. Each cell interacts with its neighbors using the following 4 rules, but let's skip those 4 rules and see the example 1 here. For the 0 here, he only got 1 live neighbor, so his next state would stay at 0. And let's see the 1 here, he also only got 1 live neighbor, and his next state would become 0. And let's see the 1 here, he got 1, 2, 3 live neighbors, so his next state would stay at 1. Then let's get started with our intuition to solve the problem. So the main idea and the key point is called state encoding. Because we have to do this, we have to solve the problem in place. So we have to encode the state to record every cells, current and future state. And let's see several examples here. As for 1, whose binary code is as for 0, whose binary code is 00, which means the current state is dead and next state is also dead. And as for 1, whose binary code is 0, 1, which means the current state is live and next state is dead. And as for 2, whose binary code is 1, 0, which means the current is dead and next state is live. And as for 3, whose binary code is 1, 1, which means the current state is live and next state is live too. So we'll use the lower bit. We'll use the lower bit to represent the current state. And vice versa. Which means we'll use the higher bit to represent the next state. So the next state will update all cells based on the original states without needing extra space. Then let's get started with our code and detailed annotations. The first step, we have to check 2 edge cases, which is board equals to null or board.length equal to 0. Then we just return and we don't have to do any further action. And the next step, we have to create several variables to help us solve the problem. Let's say we want to know the length of the row. Let's say RL equals to board.length, and we also want to know the length of the row. Let's say CL equals board.0.length. Then we have to traverse all the cells of the board using a nested for loop. Let's say for int R stands for row iteration pointer, started at 0, and row should be less than the length of row. And we have to increment row after each iteration. And the second for loop, let's say integer C started at 0, and C should be less than the length of column, which is CL. And we have to increment C. And inside the second for loop, we have to check all the neighbors, and we want to know the number of the live neighbors. First, we can have a lives variable started at 0, and then we'll use the live variable in the further code. we can have another nested for loop to check all the neighbors. Let's say int x can be assigned to math.max of r minus 1 and 0. This is because we have to traverse all neighbors and respect the boundaries. The reason that why we use the math.max is because we have to respect the boundaries of the 2D array. And x should be less than or equal to math.minimum of r plus 1 and rl minus 1. And we have to increment x after each iteration. And for the second for loop, we can initialize y started at math.max of c minus 1 and 0. And y should be less than or equal to math.minimum of c plus 1 and cl minus 1. And we have to increment y after each iteration. And inside the second for loop, we have to know the current state of this neighbor. And if the current state is 1, we have to increment lives, which is lives should be increment while board of x of y with the bitwise and 1. The reason that we use the bitwise and 1 is because we want to get a lower bit, and whose value is the current value, is current state, bitwise and 1. And out of the nested for loop, then we have to subtract the state of the current cell itself, because we have already included itself before, so we have to subtract itself, current self. So the code is lives should be decrement when board of row of column and 1. And let's come up to the next step. The next step, we have to use bitwise operations to check if the cell is alive and has 2 or 3 left neighbors. And the code is if board of row column C, comma C equals to 1 and lives is bigger than or equal to 2 and lives should be less than or equal to 3. If so, we have to update the value of board of R, C with 3. This is because cells remains alive, so we have to set the second bit to 1 from 0, 1 to 0, 1 to 1, 1. And we have to check if the cell is dead and has exactly 3 neighbors. If so, we also have to update the next state. If board of row, comma, column is equal to 0 and lives is exactly equal to 3. If so, we want to update board of R, C to 2 because we have to set the second bit to 1, which is from 0, 0 to 1, 0. And out of the the nested for loop, then we have to finalize the board by setting the next state. Finalize the board, the board by setting the next state. And we also have another nested for loop. Let's say I started at 0 and I should be less than the length of row and increment I. And for the second for loop, integer j started at 0, j is less than the length of column, and increment j. And inside the second for loop, we just do a right shift by one operation, which is right shift by 1 to get the second bit, which is board of I, j with the right shift by 1 operation. And this is all of the code. Let's check for the correctness. And then let's analyze the time and the space complexity. We have to correct at the 23rd line. It should be assigned to 3, which is not a check operation. So the time complexity, it is big O of column is I25th lives column. It should be C. So the time complexity, it is big O of length of row times length of column. Time complexity, it is big O of length of row times length of column. And the RL and CL stands for the number of rows and columns in the board. Each cell of neighbors are checked, but the operations are constant time. So the final time complexity is RL times CL. And the space complexity, it is big O of 1. This is because we use the board to store the current state and the next state. And we also create several variables to help us solve the problem, but the number of extra variables are constant. So the final time complexity, it is still big O of 1. And this is the end of my LeetCode review vlog on the Game of Life LeetCode problem. I really recommend you to visit my online GitHub page here to see all the detailed problem description, intuition and main idea, and code implementation with very detailed annotation, and the final complexity analysis. And my online GitHub page is built by Doxified. You can also see the corresponding GitHub repository here to get all the codes, assets, and notes here. And thank you guys for watching. I'll put those 2 links on my YouTube description below. And see you next time.